Hi everyone, thank you for watching this video. I'm going to take you through a brief introduction of a new tool that I developed called Threshold. Now many of you in the networking field are very familiar with tools such as traceroute, MTR, ping, iperf3, packet captures. However, oftentimes these tools are only useful if we gather the results during a time that we're actually experiencing a network issue. They may not tell us that much if we run the tools during a time when the network services are operating normally. So this presents a challenge because we don't know if the network issue will manifest itself today or maybe a week from now. And obviously, we don't have all day to sit in front of our laptop waiting for the next issue to arise. So that's where a monitoring tool like Threshold can be very useful. You can easily use Threshold in line with many of the traditional network tools that I just mentioned, and it's most appropriate for situations where the network issue is sporadic. Before we continue through this, though, let me just say that Threshold is only available for Unix and Mac operating systems. It's not available yet for Windows. So this is what a very basic Threshold command structure looks like. There are quite a few different arguments that you can use with the tool, but I'll keep it as simple as possible for now. The main thing to take note of here are the parts of this tool, which include the monitor as seen in the orange rectangle. So in our case, we've defined 8.8.8 as our target to monitor, as well as any argument settings used to tweak the sensitivity of the monitor. So for example, the -C is the count and -I is the interval at which the probes are sent out. So these arguments will tweak the sensitivity of the monitor. And all this is followed by the action to take if the monitor is breached. The action to take is defined within the quotation marks that follow the -A argument as seen in the blue rectangle. So just feel free to pause this video to look over these two parts if needed. So in this example, I've configured my monitor to continuously ping Google's DNS server 8.8.8.8. If 5 consecutive pings fail against this IP, then the monitor is considered breached at that point. Pings are sent out at an interval of 2 seconds, which I've defined with the -I argument, as I said earlier. In the event that the monitor is breached, Threshold will take whatever action we have defined inside the quotation after the -A. So in our case, I'm investigating a potential network issue in the network path, between this computer that I'm running Threshold on and Google. So I've decided to run a follow-up traceroute when the monitor is breached. Note how in my action, I have told traceroute to export its results to a text file so that I can come back later and look at them. Let's talk a little more in depth about each part of the Threshold tool. As mentioned earlier, you have two parts of the tool that need to be configured: the monitor and the action. For the monitor, there are currently 3 types which you can use. The first type is a time-based download monitor. For example, let's say at random times throughout the day, you've noticed that downloads from your website are taking an abnormal long time to complete. In this case, you can set up a time-based download monitor, which will continuously pull down a file from a URL that you've specified. It will do this in a loop until either the file download takes longer than the time that you've specified in the monitor, or you manually stop the monitor. I'll give a demonstration of how this works in a moment. The next type of monitor is a successful ping test. This is a simple monitor that waits for a specified amount of unsuccessful consecutive pings before considering itself breached. If you recall in my earlier example, I had set 5 unsuccessful consecutive pings as the criteria for a breached monitor. The last type of monitor is the successful TCP handshake. This will continuously attempt to gracefully establish and tear down a TCP handshake with your target. If Threshold fails to establish this handshake after so many consecutive attempts, the monitor is considered breached and the defined action will be taken. Now, as far as the actions part of the tool, it can literally be any command you would normally be able to run from a Linux command line. It doesn't even necessarily have to be an action to execute a network-specific tool. It can be anything such as commands to rotate logs or rotate logs on the local computer or make API calls, anything that you could manually execute from a Linux command line. This, of course, makes Threshold a very flexible and useful tool for a lot of different use cases. The only caveat to defining actions is that you will want to avoid using special characters which are recognized by Unix systems as having special meaning, such as the $ or ampersand. The actions may not always execute the way you want them to in this case, so you will only want to use these characters with caution. All right, so here I have a terminal window open on a Linux EC2, but again, this should work with any type of Linux or Mac operating system that you're using. I want to show you some basic commands and things you can do with Threshold monitors. To get started, you'll want to install Threshold. The step on how to do this can be found on the GitHub page for Threshold, and I've put a link to that page under this video. Basically, you're going to download an installation script with curl. So I'm going to copy and paste this command now and hit enter. All right, so now it's downloaded an installation script, and then you're going to execute the installation script with sudo sh install, like so, and hit enter. And that's all there is to installing Threshold. Now that we have Threshold installed, let's go through a scenario where a ping monitor may be the most appropriate type of monitor to set up. So we'll say that we've been having a lot of sporadic connectivity issues between my EC2 here and some remote host out there. That remote host IP is 192.168.3.241. Been seeing a lot of issues there, and I suspect that it's probably due to some packet loss and high latency somewhere between my EC2 and that host. So a ping monitor is most appropriate in this case. Let me just show you the command and we'll kind of talk about it as we go along. So sudo threshold-c, and I'm going to set a value of 3. So this is, again, setting the sensitivity of the monitor. -c in this context stands for consecutive count. I've basically said that if 3 ping packets fail response from the host, then this monitor is breached at that point. You define the target with -d, and then I said the IP was 192.168.3.241. And just for kicks, I'm going to add one more argument to tweak the sensitivity of this monitor, and that is the I or interval. I'm going to set this to 2. So every 2 seconds, Threshold will send out a ping packet to this target. Now, if you multiply the interval by the consecutive count, that makes up for 5 seconds in total, right? So if this target fails to respond consecutively over a period of 5 seconds, then this monitor is breached at that point and the action will be taken. You define the action with -a, then open quotations. And I think an MTR test is most appropriate for this as a follow-up action. For you that aren't familiar with MTR, MTR is like a hybrid between traceroute and ping. Just gives a lot more information than either of those two tools, so I use it a lot. So let me set up an MTR action here. And we'll just keep it very basic. So MTR 192.168.3.241. And then I want to export these results, this MTR results, to a file on my local machine. So I'm just going to call these results.txt, and then end of action with the close quotation mark like that. You can optionally set the P argument. This stands for persistent. What this means is if Threshold triggers, or if it's breached, it's going to execute the subsequent action, but then it's going to respawn itself again. So you're just going to continuously have these Threshold monitors running until you stop them manually. Alternatively, if you remove this argument, then the monitor is going to trigger once, execute its action, and then it won't respawn anymore. It's important to say that, well, let's just run this real quick. Before you set up any monitors like this, you want to make sure that those monitors are initially successful, right? They don't just immediately trigger as soon as you execute them. For example, my monitor is a ping, so I'm going to make sure that I can actually ping that target. I should have done this before executing the threshold monitor, but here we go. 68.3.241, and I can confirm that I'm able to ping that host. So I know this this monitor is appropriate and legit. You can check on your threshold monitors. They're running in the background with threshold-L. You'll have to run this with sudo, by the way. And there you have it. You have the job ID, the type of monitor that it is, so it's running every 2 seconds. If there's 3 consecutive failures, the alarm will breach, and then the follow-up action to take if that monitor is breached. Next, let's go over a TCP handshake monitor. This is most appropriate when you've been experiencing TCP-specific connection issues. For example, we could say that I've been noticing a lot of SQL database connection errors in my application logs lately, and these have been happening at random times throughout the week. My network team has determined that a raw packet capture during one of these events is most appropriate, so I want to set up a monitor for this. Before we do this, however, let's make sure that we can create a successful TCP handshake with our database target. And remember, SQL uses TCP 1433, so I'm going to use netcat to try to establish a TCP handshake on that port. And our database IP is 192.168.3.37 in my case, and port 1433. Okay, so we can see that I'm able to make a TCP handshake with my database. We can go ahead and move forward with setting up the monitor. So here I'm going to type in sudo threshold -C6. Again, -C means consecutive count, so if 6 TCP handshakes fail against my database, then this monitor is considered breached at that point. I define the target with -D and then the IP of my database, 192.168.3.37. And then -P to define the TCP port we're running this monitor on. SQL uses 1433, so I'm going to put that. And then -A to define the action if this monitor is breached. So again, the network team wants me to run a packet capture, so I'm going to do that using TCP dump. So we'll just keep it really simple for demonstration purposes here. TCP dump host 192.168.3.240, So what I've done here is I've set up a TCP dump packet capture, and it's filtering for traffic to and from this particular host. And then I'm going to set a buffer in TCP dump with the -C flag. And I'm going to just set this to 10,000 bytes. This buffer to 10,000 bytes. This is really important because if your action does trigger, let's say in the middle of the night while you're asleep, you don't want to come back the next day and then have an output file the size of your hard drive. So it's really important to set some kind of limits with whatever kind of actions you're running. All right, and then finally I want to write this, sorry for the formatting here. This is all really technically one line, but I went to new line here. So -W. I'm going to write this output to a file called db.pcap. With TCP dump, the -W means that I'm going to write the output in a Wireshark format so that I can actually take this file and look at it in Wireshark later on if I need to. Okay, I'm going to end this action using the closing quotation mark there. And then I do want this job to be persistent. I want threshold to respawn itself if it triggers, and so that I'm just having these jobs run throughout the night. Okay, so I'm going to execute that, and then if I do a threshold -L, you can see all of my jobs running. As you can see, I have the ping monitor that I had set up earlier. I'm sorry, that's the TCP handshake I'm looking at. The second job is the ping monitor that we set up earlier. And this is the TCP handshake monitor, which we just now set up against TCP 1433. These TCP handshakes are going to run every 5 seconds by default. If there's 6 consecutive failed handshakes, the alarm will breach, and then here's the action it will take. Last but not least, I want to demonstrate how to use a time-based download monitor and talk about when it's appropriate to use. So let's say that I have a website and I've been noticing lately that the web pages on that site have been taking an abnormal amount of time to load. In addition to this, I'm also noticing that when I download large files from that website, they take a much longer time to complete at random times throughout the day. So after testing downloads under normal circumstances, I've determined that these files should take no longer than 5 minutes. Hence, I've established some kind of standard for what to expect in terms of time and how long it should take to download these files. Other troubleshooting over the last few weeks has indicated that the long downloads may be due to bandwidth throttling somewhere between my EC2 here and that website. So I've decided to use a tool called iPerf3 to measure the bandwidth between my EC2 and that site. If you're not familiar with iPerf3, then I would recommend just checking it out and reading up on its documentation. But before we create this threshold monitor, I will want to run an iPerf3 test between my local EC2 here and the problematic website to determine what the throughput measurements are under normal circumstances. Again, I'm just trying to establish some kind of standard of what to expect in terms of throughput, so that I can compare that to the throughput when the issue arises again. All right, so assuming now that we've benchmarked the expected download time and the max throughput to my website under normal circumstances, let's set up this threshold monitor. Now note that this particular monitor can get pretty lengthy to type out, so all of the command that you're about to see on my screen is really one single line, even though it may appear as multiple lines. If the command I'm typing out seems jumbled or confusing to you, I would recommend also taking a look at our threshold documentation, and it'll give you a clearer example, a prettier example of what I'm typing out here. All right, so let's get started. I'm going to create this monitor with sudo threshold -d to define my target website, my target host, and I'm going to put HTTP, and in your case you may be using HTTPS. It really doesn't matter, one of the two, but whether you use HTTP or HTTPS, this is telling Threshold at this point that this is going to be a time-based download monitor. All right, so my makeup website here is mywebserver.com, and I want to define the path, the URL path to the file that I've been having trouble downloading or the slowness with, and we'll just say that that path is some 100 megabyte file.zip. It's a zip file, and this could be completely different for you. This is just for example purposes, right? All right, and then again, I determined that under normal circumstances, this file should take no more than 5 minutes to complete download. So I'm going to set that as my limit. And Threshold's going to go through, it's going to download this file in a loop over and over and over continuously. And as long as it's under 5 minutes, it's going to continue that process. If it takes longer than 5 minutes, Threshold will breach. It'll be considered a breached alarm, and then the subsequent action will be taken. So you define the action again with -a, open quotation marks, and then as I mentioned earlier, we're going to use iPerf3. So iPerf3, I'm setting my EC2 as the client side. I'm not going to get into client server roles in iPerf3. That's outside the scope of this video. Just read up on iPerf3 whenever you get a chance, okay? The action really doesn't matter. This could be any action. I'm just using it as an example here. So iPerf3, I'm going to set myself as the client, and then the destination as my web server.com. And then I want this iPerf to run for 300 seconds as well, so 5 minutes in total. And then I want the results of the iPerf test to be written to a log file called results.txt. Again, this is all really one line, even though it's wrapping it here. Okay? And then end the action with a closing quotation mark. Again, I want this to be a persistent job that runs continuously, so I'm going to use the -p argument and hit enter. And there we have it. We have a job running in the background, and we can see this by running threshold -l. Oh. And some of my other jobs have already completed, like I had a ping job running earlier. I think that's executed. So that's why you're not seeing it here. So yeah, here's your time-based download monitor. I know it's really kind of hard to read. You can expand the terminal. I can't do it here in this video because it would mess up the resolution, but you can see the job here. Okay. I hope this video has been helpful to you. Please feel free to leave any comments or questions under the video in the comments section, and I'll do my best to answer those for you. Thanks.